Hello, everyone, and welcome to this webinar, Integrating External AI Agents in Industrial Workflows. This is going to be a very deep topic today. So before we get started, a few items of housekeeping. First thing, feel free to introduce yourself in chat. We've been doing that for the past couple of minutes, but I'd love to know both where you're coming from and how this topic is impacting you. Secondly, this webinar is being recorded, so we're going to send a link when it's available. Please use the Q&A panel for any questions. That way we don't miss anything. And at the end of this webinar, a short survey is going to pop up, so please share your feedback to help us shape future sessions. And we're actually going to have a couple questions that we sort of pepper throughout this. So feel free to jump into those as they appear. With all of that said, I'd like to start today by going through a little bit of a presentation. I promise you it's not going to be just presentations this whole time, but I want to sort of set the stage here. What we're really talking about today, this broader topic of integrating external AI agents, really it comes from a very specific problem. And this problem it has a lot of context to it. And so before I get into sort of the solution and sort of the context of that solution, I'd like to first give you an idea of where this problem came from. So I want you all to sort of rewind your brains, go back to the 70s and 80s. I am old enough to remember a time where hard drives were actually like ludicrously expensive. You were lucky enough to have kilobytes of data, let alone gigabytes of data, or terabytes or petabytes or whatever. And so there was this time where we had industrial data that was being generated. And the question was, okay, how can we make that data actually useful for us? How can we get information from the data? How can we leverage it to give us better insights? And so the initial problem that we had here was, okay, the theory, what we're going to apply to fix this problem is that more data in aggregate is going to expose value in some way. That was the theorem. And so what we did to sort of solve that problem in the industrial space is just collect everything, have every single system generating data, collect that data, collect context about that data, just bring everything into this massive storage medium. And over time, that went from being something that was sort of an edge case or something that was very expensive and sort of theoretical. We went away from, hundreds of dollars per megabyte for storage to 100 gigabyte hard drives to terabyte hard drives, and then further into petabytes and then into database sharding. And so we got into this weird sort of dynamic where industry is generating this data and that data was being siloed in a lot of different places. And as our storage grew, we didn't really solve the problem of getting information from that storage. We just put that data in more places, which is not the actual solve, right? And so that generated a new problem, a very interesting problem, which was, okay, we have all this data in one place or in several places. How do we actually generate information from this? We finally have the abundance that we desire, right? The solution was, okay, well, let's figure out a way to make this, interactive, that we can go out, we can take that data, we can run queries on it. And I think if you talk to the average comp sci graduate, the average IT person, the difference between courses in the 90s versus courses today is all about database interaction. It is about, now it's also about AI, but we'll get to that in a minute. But it's largely about database interaction. It is, okay, we have all this data. We need to learn SQL. We need to learn different ways to interact with things like MongoDB and QuestDB, and what's the difference between time series and relational. And it's a much bigger focus than it ever was before, because now we have the storage part of this figured out, but we don't have the interactivity part of it figured out. Okay, so that was sort of the way it was. As this moved forward, and I think you all have probably experienced this piece of it in the industrial space, well, we finally have the tooling to interact with that data. Great, perfect. But in order to actually surface that interactivity, we had to move away from simple SQL queries and database unions and all these like complex functions. We had to take that functionality and we had to get to a point where it was containerized, or it was sort of like application platform contained. And that surfacing necessarily added complexity. And so we got to this weird place where we had all the data. In theory, we had the systems to interact with that data, but actually interacting with anything was really, really complicated. It became almost prohibitively so. And then the answer was, okay, well, we have 100 different applications to interact with data. So let's make standards, right? If we all have standards, we can solve this problem. You saw things like in 97, I think it was when MQTT was published. You saw that come to the forefront. You saw all these sort of like moving away from SOAP and into more RESTful architectures. So you saw a lot of API microservice sort of data accessibility solutions. The problem, though, is that as we moved along that track, we got to what is arguably one of the most famous XKCD comics, which is how standards proliferate. And the problem here was, okay, well, we have 14 standards. We have a bunch of ways we can interact with data. It's crazy to have this many standards. 14, what are we doing? We need to make a universal standard. And then what you get out of that is not one universal standard. You now have 15 standards. And this is the story over and over and over again, that every time we've tried to solve this problem, we've run into this critical issue. And so we had this really odd changing landscape. Excuse me for a second, I'm going to drink some coffee. The changing landscape here was that we were over collecting just to collect. Now we have to act. But that action necessarily was tied almost as a dyad to the ease of implementation. Okay. So you had this action pressure, which was, we're collecting data. We need more data. We need more data. Okay. Well, now we have data. Now we need insights. So let's collect everything we can and try and get some insights from it. Okay. Action pressure is rising. Ease of implementation is still reasonably easy. Just get more hard drives, right? It's horizontal scaling. That's fine. The intelligence demand then became a thing. Okay, we have all this data. We have to do something with it. Now the action pressure is rising. There's more pressure from investors, more pressure from C-suite, more pressure on engineers and operators who are actually in situ. You have to do something with this data, but the ease of implementation has gone down. Now it's not so simple that we can just add hard drives. We have to actually add like processing to that system. Okay, and now we are where we're finally at today, which is the demand for flexibility. It's not good enough to just have that information. It can't be a pain to get that information. We have to have instant insight. We have to have immediate time to value. The expectation for the action keeps rising. The demand is you must get value from your data, and every system connected must generate data. You must capture it. You must work on it. And yet necessarily the ease of implementation has crashed. And so what do we do with that, right? What is the answer? The answer to this point is sort of what we're talking about today. One of them is the idea of external AI agents. So before we go into this broader sort of topic, I do want to clarify a little bit about what actually an external AI agent is. So before I get into that, I actually have a question real quick. I'm going to launch this poll. I'd like to get an idea from you all as to how technically familiar you actually are with AI. Because a lot about what we're going to be talking about in a moment is going to be quite technical, and there's going to be a lot of sort of clarification in terms of the terminology that we're talking about. So I just want to get a sense of where we're starting. So far it seems like we have, and interesting, we have sort of a bimodal distribution. So we have quite a few people consider themselves to be like 8 out of 10 in terms of AI. But we also do have quite a few, we're actually trimodal now. We have quite a few people who are sort of middle of the road, around the 5-4 area. And then we actually have a pretty big grouping around 2 and 3. So I'll give you just another minute as we wrap up that poll. I'll get back to the term definitions briefly. So when we talk about external AI agents, before I get into the real deep details, what I want to clarify here is what an external AI agent actually is, okay? When we talk about external AI agents, we're not talking about the locality of the system necessarily. We're not talking in the sense of, if you think about like the way that thin clients versus like a regular computer is, right? In a regular computer, a thin client may be getting your OS remotely and then loading it in. You may be getting server stuff. You could say that's like an external OS, and then your internal OS is like baked into your computer. That's not really what we're doing here, because there's some abstraction there of data control, the nexus of control for data. When we talk specifically about external agents, we're more talking about the control and the data that interacts with that, where that is located in relation to the AI itself. So let me give you an example. When we talk about internal AI agents, we're talking about a platform or a solution-specific implementation, okay? A good example of this would be like the FlowFuse Expert. Fantastic piece of product. I love FlowFuse Expert. It is a platform-specific solution that works within FlowFuse, okay? It's tightly coupled to the way that you've designed it, the way that FlowFuse has designed it, and it has this sort of indirect governance pattern, which could be good or bad. In FlowFuse's case, it's great because FlowFuse is one of the few offerings that give you the ability to do granular role-based access control and governance rules and everything native into the flow. But if you're using another platform that didn't have that, obviously you would be tied to their governance. And so that gets a little complicated. One interesting thing about the internal AI agent is you usually get sort of a direct control nexus that comes with low latency, but has low data costs additionally, because you're not really storing the data. You're not really managing the infrastructural piece of it. You're using someone else's platform to do the thing. The problem, though, is that you have an indirect model choice, okay? In some cases, like FlowFuse is a great example, because FlowFuse gives you both the ability to use the expert, but then to also bake in your own external agents. And so if you were on a platform that didn't have that option, you would be locked to whatever they've decided to use. So there's industrial AI platforms, are a dime a dozen at this point, and some of them say, okay, we're using OpenAI. That means that you are forever locked to OpenAI. If you're using Anthropic, you're forever locked to Anthropic. Like, that's your choice. And so in some ways you get direct control, in some ways you get indirect control. But you also tend to get a higher cost with that implementation. And the cost, ironically enough, has nothing to do with like the low latency, the data costs, all that. It actually has to do with paying to access the platform. So I'm sure you all have run into this before, where, you know, it's a $400,000 implementation cost, and then but they're like, oh, you don't have to pay per token. Well, yeah, because I paid $400,000 for the implementation costs. Like, that's not, cost is cost, right? The external AI agent changes the game a little bit in some interesting ways. Okay. I'll close the poll in just a minute. It looks like we still have a couple people answering. So for the external AI agent piece of it, what's interesting here is it can still be on the platform. It can still be using tools on whatever platform you're using. But what is happening is you're actually sending out the data for processing by some other externality, some other external system. Typically, you would see this like you're sending out to OpenAI, right? Or you're sending out to, you know, a llama or something. That is interesting because you are now loosely coupled. You're not tied to the data itself. And in fact, I'm going to show you an implementation in just a second where you can see what that means. You get direct governance, which is great. You can completely control the data flow, which again, if you're not on something like FlowFuse, you often don't. The multi-hop, though, that is a killer. The fact that you have to send out multiple connections, you have to route to an external agent, you have to, you know, parse that response, you have to then take that response and connect with the database somehow. All of that gets a little complicated. And you also now have a hybrid model choice. You have to actually figure out what model you're running. And it gets to this weird state where you have direct control over how the model is processing. You have the lower cost, but your scope necessarily gets crushed down. And I'll get into why necessarily in just a moment. So all that being said, let me go ahead and end the poll, and we'll look at our distribution. So yeah, we actually have a really interesting distribution here. Most of us here are split between 8 out of 10, 7 out of 10, and 5 out of 10, with a little bit at like 3 and 2 and a couple at 1, which is actually good because I will get into this next section, which is getting into some of the finer sort of technical details. Before I do that, actually, I want to show you a little bit about what we are functionally talking about today and why this is sort of quite important. So what I'm going to show you today is a couple different things. The first thing I'd like to show you is the two servers. I have two servers right behind me that we're going to sort of walk through AI on this system for the external local AI agent. So this is half the equation. Before we get into the sort of other technical information I want to share with you, I want to set the stage. So we have all of this local model processing that is happening. In addition to this local model, I'm going to show you some of the remote external resources, but I really want to hammer down right now before we get into some of the sort of finer technical details that an external agent doesn't necessarily mean that it's not local. Okay. An external agent could be a remote external agent, or it can be a local external agent, which is a little bit of a brain shift, right? That is somewhat different than maybe we would refer to this topic previously. Like it's a small shift in the way that we think about this structure. Okay. So as we talk through the rest of this, what I'd really like you to sort of keep in mind is that this is as much about internal is now platform, external could be both remotely co-located or locally co-located. When we talk about external agents, that co-location part that I was just talking about comes down to this, okay? So what are we actually looking at here? Because this is kind of a wild thing we're looking at. What this is, in many ways, is basically like ChatGPT or Claude or any of these systems. The problem is that when you're using an AI system that is not a remote resource, you're not going out to Claude.ai or ChatGPT or whatever, you have to do a lot of these sort of structuring that they're doing on their side. You have to now take on that burden to do on your side. And the reason I share this now before we get into the technical part of this is to really get you to understand why it's important to understand some of these technical pieces, because this entire structure, this is usually handled by them. We now, because we're doing external AI, because we're doing local AI, we have to understand how these systems function, and we have to understand at scale how each of these pieces play together. This is a complicated thing to wrap our head around. When we talk about AI, AI is a much broader topic than just LLMs, okay? It's a very, very specific thing. And this split, for lack of better terms, of understanding has complicated the conversation because it's not always easily understood outside of like a couple circles. So let me set that standard for you now. If you picture AI as a giant circle, okay, a huge AI sort of topic space. Within AI itself, we now have a smaller circle that is within AI that we call machine learning. And the idea behind machine learning is exactly what it sounds like. You take your machine, you give it a bunch of data, it learns certain things about that data, and it's able to then predict certain instances, certain recurrences, and it's able to sort of understand what that data may suggest, okay? Now that part of it, you have to go a step further, because just understanding the data doesn't really give you any actionable insight, doesn't give you an ability to go the next step. And so what you need to do is go to the next layer, which is deep learning. In deep learning is this idea of you take all the contextual information that you have, and then you infer the relationships between each data point, each meta contextual data point, the context of the conversation that you're having, the history of that data. All of that needs to happen in order to actually deeply learn about a thing instead of just recognizing a simple contextual connection. I'll give you an example. If you drive your car and you go to fill up on gas or petrol, okay, you have spent, let's say, 5 years of your life driving the same car. You know that when you pull up to the gas station, you either have to have your car aligned with the pump to the left or the pump to the right. Now, if you were to just process on like a machine learning scenario without doing any sort of like deep learning, you would look at that and say, okay, every time this car comes into the station, it parks with the pump on the right, and therefore every Toyota has its gas pump on the right. Well, that's not necessarily true, right? If you do the deep learning piece of it, then it'll look at that and say, okay, this person's driving this model of car. This model of car was built in this way because it's a left-hand drive or a right-hand drive. It's in this country, which is more likely to have left or right aligned gas caps, and then so forth and so forth. And it gets the sort of contextual understanding of why specifically in this instance you pulled into the gas station in that particular way. That deep learning can then be leveraged to what we're really talking about in the general sense of things like Claude and other systems like that, which is generative AI. Because you now know and understand all that meta contextual information, you can now generate another car, an image of a car, schematic of a car, whatever it is that has that gas cap oriented in the same way. Or you can ask it a question like, hey, I want to build a car in Italy. How do I, where do I put the gas cap in the gas port? It'll be able to infer through its deep learning that in most cases, the answer looks like this. Okay. There's more to deep learning, more to LLMs we'll get to in a second. The thing about all of this, and specifically about external AI, is that large language models don't actually learn anything. They don't have the ability really to learn something in the sort of epistemological sense that we can learn. What it does, however, is it can reason, and I use that in quotes, it can reason over data it's already seen. And that makes it perfect for industrial data because you can feed it all of your sensors, you can feed it all of your information, and it can look back at that, it can do the deep learning on it, and then it can say, okay, when this sensor has appeared, the next thing that has happened has been a request for repair or, maintenance downtime or something. That thing, that recognition that it can do makes it really, really uniquely suited for what we're trying to use it for, okay? And again, just to hammer down before I jump into the actual demo here, local external AI agents are a really interesting carve out because although they are an external AI agent, okay, so they're outside of our system, they can be local. They can be Claude or ChatGPT. It sounds like, oh, well, there's ChatGPT and then there's local. Well, no, you can deploy a local Claude instance. It can be open or closed source. There are dime a dozen providers that do local external AI systems that are closed source. But the thing that I really want you to keep in mind, and I'll hammer on this a couple times throughout this, is that it's extremely, extremely cost dependent. Okay. The problem with using external AIs via a platform solution is that for most platform solutions, their core sort of bread and butter offering is typically not the AI. It's all the other things plus the AI. And so you typically get a more cost performance solution, whereas using an external solution, you have to pay for token calls. You have to pay for the server to have the local LLM. You have to pay for the processing, the infrastructure. You have to pay for all of that. And so it's sort of this continual resourcing cost. Okay. So that is sort of the standard that I wanted to start with today. Let's dive into some practical examples. Let's look at the actual sort of flows here. The way that this is set up, and if you'll remember from when I showed you the server, we actually have sort of a blend of cloud instances and remote instances. We have a couple ones that are really relevant to what we're talking about today. This first one, I'll just briefly show you because I'm going to get really detailed in a moment. This is handling our off-premises external AI. So this is sending, in this case, out to Claude, or Anthropic, I should say. This on-premises agent is actually sending to a local Olama, which I'll show you that as well. And then we have a local ONNX thing here, which I'm still working on, still iterating on, but I'll show you what comes out of this. It's not quite ready for prime time, but it's coming if you're going to Hanover Messe, you will see this in all of its glory. The other thing I want to show you real quick is this. Now, when you start talking about local AI, one of the things that you have to do that you sort of take for granted when you're using Claude or any of those systems is you have to handle the infrastructural connections to make it work. And so when you send something out to Claude, you don't really have to care about what servers Claude is running. You don't have to care about how they're handling data. Because you're now running something locally, you do have to care about that. And so in this case, we have a remote instance that is called AI Bridge. I'll show you what that looks like in a few minutes, but it's basically just a project makes a call of a llama. This is a custom node that I've written that I will share on GitHub, but it's basically just calling the local URL on the server that I showed you. And I'll also show you the setup there in just a moment. And so all of this is basically handling that remote sort of, if you can imagine the cloud instance, you make the request on cloud, it goes down to the remote instance, does the processing, brings it back up. The reason we do it that way is because the remote instance, you may want people to be able to access this dashboard or this sort of AI agent without actually accessing your remote instance. You may not want them to have native access. And so this gives you the ability to do that. The other thing I'll show you is this flow. Now, this flow is doing all of our database capturing. And so the way this basically works, this is a QuestDB instance. I'm not going to show you the configuration because it's got some IP stuff in it. But it's basically just coming in as a project link. It's making a request here that is select, I think it's select wildcard from the table name limit 1,000, I believe, and just pulls that out. And then it converts that over to a string because it's much easier to port strings back and forth than it is to port arrays, at least when it comes to Anthropic. And so this is just handling the data side of things. Now, the other piece here, which again, not quite ready for prime time, but I'll show you kind of what it looks like right now. I have a camera request. This is actually browsable because it's a local. So I have an API call that is secured. That is going out to a snapshot image of a webcam that I have set up behind me, and it's taking that frame and then processing it for local models. So I can process this as, like an ONNX request, and then I can send that out to the agents that we were talking about. Okay, so that is sort of the underlying infrastructure. Let me show you what it actually looks like. Here, I'll do our off-prem first, okay? So if I were to ask this agent something like, or if I were to tell it a fact, let's say my dog is named Usagi. Okay. This is actually true information. My dog is a Shiba Inu. She's named Usagi. And yes, I love Sailor Moon. So here we go. That's a cute name. Usagi means rabbit in Japanese, et cetera, et cetera, et cetera. Okay. I'm going to not answer its question. I'm going to give it more information. My cat is named Ushi. Okay. So then it's going to process that information. It's thinking, nice, Ushi means cat in Japanese. Seems like you have a fun theme going. Cool. Awesome. See, I'll just sideline real quick. I see a question in chat. Is the standard capability from Node-RED, or are these modules packaged by FlowFuse in Node-RED? It's a mixture of both. What I'm going to show you in a minute actually is natively available in Node-RED. You can do it with HTTP nodes. For some of the more complex, like ONNX stuff, those nodes are publicly released, but it's a little bit complicated. So, and then your next question about agents processing data, local buffer, I'll show you that because we're actually going to get into the details here in just a second. So now we have these two facts that the agent knows about. They know I have a dog, I have a cat, they know their names. I can now ask the agent a question like, what are the names of my pets? Okay, let's send that request. And it will process. I'm thinking. Your pets are 1 Usagi and 2 Ushi. Cool. Awesome. So how does this actually work? What is the structural component of this? So, sorry, let me find the right instance. So this instance is what we just interacted with. Again, and this is sort of the struggle of the external AI solution. We have to do all the things that Claude does natively. We have to think about all of those pieces, especially when we're talking about more complex data, which we'll get into in a minute, especially from the industrial point of view. So in this case, if we're looking at our dashboard, we have this input, we have a send button, we have the response, we have clear history, inject data. Now, the way this is essentially working is we have our dashboard elements. These are all the things that we just saw. We'll end this as well. Okay, we have our user input, our send, our clear history, and our response. In order to pass the context of the message history, the sort of thing that we take for granted, right? If you go and talk to Claude, it'll remember the last message that you sent. What is actually happening on our side is we have to store that content somewhere. And so what we're using here, sorry, wrong sub you. What we're using here is we're using flow context state. Now on FlowFuse, what you can do is these things that are coming in, you can flow that. I mean, you can do it on Node-RED too. So on these systems, what you can do is when those messages come in, you can store them in a state either temporarily or long-term for additional processing down the line. So when the user input happens, we store that input silently, and we're storing it with a key pending input off. And off in this case is not on or off like as a binary. It's off saying that it's part of our offsite flow. It's just a key differentiation. So when we have that user input, we store that for the pending input off. And the reason we want to store it instead of just send it is that this request, if we were to just go by user input, if I were to write my dog is named and then pause, that would process as a message, right? So we need, again, to think about things that we don't have to think about when we're at Claude, Claude.ai or ChatGPT or Gemini or whatever. So then we have this sort of other process, which is the send button. And the send button basically reads our stored input, which gets stored in pending input off. I should actually refresh that. In fact, let me add something here. What is the kind of, or what kinds of pets do I have? Okay. Before I actually hit send on that, that'll get stored as the actual pending input. So it's getting cached sort of live as it's happening. Now, when we hit the send button, it pulses to read stored input, goes to our build messages array. And this basically just pulls not just the pending input, but also the conversational history. And that conversational history is being stored as a series of objects that are all of the interactions that we've had with this agent so far. And you can start to see that, well, first of all, you can see the complexity that we have to build into this process because we're not Claude. But you can also start to understand why, if any of you have ever used Claude Code, for instance, you get to a certain point where it says, hey, you're running out of context. Like, we can't, you need to stop. Where that comes from is because it as well is doing this. That every message you're sending, it's having to actually reference previous conversational context. Okay. And that creates this interesting problem for us because we don't have supercomputers, right? When we can do just like the Claude requests, this is an okay scenario to be working with. This is not too much context. But if you're generating hundreds of thousands of rows of data, in fact, the QuestDB that I have running right now, I think this morning was up to 790,000 rows of data. If I wanted that data to be processed in its entirety, I wanted historical data from the point that my factories have been running till now, you have to sort of understand that that's going to take some time. And it's going to take some time, not necessarily just because it's a large amount of data, which it is, but because every piece of data that you're adding into that reduces your context window as to how much the model can actually understand at one time. Okay. That's going to be really important in a minute. I'll show you why that matters so much. Okay. So we'll get out of this. This message array is then sent through the Anthropic API, which is, it's just a request. That URL is actually generated in the build messages array, which is down here. You'll notice I'm using an environment key. Who's using an environment key? It's really simple to set up in Node-RED and FlowFuse. They're very valuable to do. And then it just sends the API messages endpoint. And what's key here is this flow can be sent to any API, any open API, as long, not open API, the company, but any open accessible API. As long as you have the authentication key, you can send it out. Now, once this is triggered, we trigger the show thinking to let our user know that, hey, we're processing. Then we have the actual API handling. We then save that response to history. So we stringify it and we save the response that we got back as sort of context history here. And then this content, because it's set in the flow state, is now an object that you can replicate anywhere. Okay. That flow state can be sent out to a company-wide database for referencing, It can be sent to a CRM somewhere. It could be sent literally anywhere. It is now that message object can be portable in any way. Okay. Anyone who accesses this instance can see the flow state. You can publish it to a global state, export it elsewhere. You can do anything you want with it. One thing I'll note here is we do have like a general purpose API error catch, which then triggers a retry with backoff and a delay. Basically, if we're overloading the server, it'll wait a couple seconds and try again. We also have a solution here to clear history. And so with all that said, if I wanted this to do something more complicated than this, right? This is kind of nonsense. I'll clear history. You'll see when I hit that button, I'll come back to our flow state and our conversation history gets cleared. If I wanted to act upon some data, okay, what I really want it to do is come down to this instance and collect some data that I can work on. If I click this button, inject data, this is just a manual way of doing it, but it could be automated literally in any way. You could automate it through pulses to like constantly collect the last 1,000 entries. You could do sort of like you would on Linux to do like a tail for the log. You could do this in any way. I'll go ahead and click that inject data, and you'll see that a trigger message was sent down the pipe, and we got back this payload. That this it's 100, not 1,000. That could be 1,000, it doesn't matter. What we end up getting out of this array, it's an array of 100 pieces of data, and you can see we have the context of the topic that it's reporting on, the site ID, the value, the sim timestamp, because this is all simulated, and then the wall timestamp when it's actually posted to the MQTT sort of pipeline. Then we have some other elements like this is a running binary. This is an actual value. So in this case, this is a vibration in millimeter per second. So you can get all of your data in that way. This data, again, gets converted over into a string, gets pushed back out through our project out node. And now that we have this here, I can say, what can you tell me about this data? And is there a machine that has high vibration reporting? Okay. We'll send that over to the AI. Now, what we're doing here is we're not just sending the input that we have, which is the pending input here. This is actually already sent, so it's being blanked out. We're also sending the data array itself. So we're merging this data array with the request, and that's now being processed. So this is not pretty, I'll say that right now, but you can say, okay, this is real-time industrial, blah, 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 telemetry. It'll tell us all the things that we need to know about it. It'll tell us the high vibration. This is now a data object. So this can be ported anywhere, can be remixed, can be formatted, can be restructured. You can extract data. You can say like detect where, in this particular sort of matching string, this is the data I want to extract from it. So you can get pretty instantaneous insight of your data. Now, what is difficult about this? So Bartholomew mentions it's already in Markdown. Yes, I ask most of my agents to do in Markdown because it's easier to port around in that way. Where this gets a little complicated, however, is when we talk about the reality of on-prem agents. Okay. Again, we're not Claude. I wish we were Claude. We're not Claude. Let me show you what our servers currently look like so you can see what is actually powering this interaction. Okay. So I'm going to show you this tool. This is Rust Desk. If anyone is familiar with Rust Desk, it's an open source sort of remote access solution. Unfortunately, is used quite widely for scams, but is also used quite widely in IT. So what are you going to do, right? We have two servers that are working right now. On the one side, we have this server. This is the QuestDB that I was talking about. Oh, we're only up to 675,000. Great for my data, right? And it's just generating a ridiculous amount of data. It is every minute it's generating 6 pulses of data, something like that. It's simulated, so I wanted to be a little bit easy on our broker. And then we also have sort of a collection here of devices that are all doing different things. We have QuestDB, and then we have QuestDB being served up to the QuestDB handler. We have Odoo installed here. We have a couple different sort of factory simulation devices that are happening. All of this is on one device, okay? On the other side of things, we have this view. Now, this view is actually quite a bit more complicated. This is not only our containerization for our computer vision. So we're doing go to RTC, which is basically taking an RTSP stream from our camera and it's converting it over to something that we can access through an IP. That's one thing. We also have a camera server that's pulling that. We have an AI bridge that's doing a lot of our connectivity. We have a lot of the services that we were actually just looking at are split between these two machines for different reasons. What is most important, however, is this. Okay. I'll show you what we have. So we have a llama installed. You could do llama.cpp. It doesn't really matter. We have a llama because we wanted both to have a local GUI interaction with the llama as well as an API. And the two models that we have installed here, we have llama 3.2 1 billion quantize, and then we have the Qwen 3.59 billion quantize. Now, to be clear, what I mean when I say quantize is these are bigger models that are sort of sub-segmented into smaller quantizations of the larger model. You get better performance, which is nice, but you also lose a little bit of context. So if we were to send this remotely, what does this actually look like? What do we get out of that? Let me go ahead and get back to our instance over here. If I were to ask it a series of questions, let's give it some more facts, right? Let's do the same demonstration we did with off-prem. My dog is named Usagi. Okay, we'll send that. You can see it's doing a little bit of processing here. It kicked off a runner. It's going through all of the tensor pieces. Okay, Usagi is a lovely name for a dog. Okay, which means beautiful bird. Now, I named all my stuff Japanese for a reason because I spend a lot of my time in Japan, and I can tell you that that's not what Usagi means. Usagi means rabbit. Okay. So that's just not, that's hallucinated or it's inferred from something else. Okay, whatever. We'll go, my cat was named Ushi. All right. It'll process, thinking, great. Ushi is a unique name. Okay. It means ox or bullock. That's not at all what it means. So if I ask, okay, what are the names of my animals? What we're going to get back from this is going to feel similar to what we would get from the other model, but it's prone to hallucination and it's prone to losing context. Here we can see a conversation has just begun. I'd be happy to help you with information about your animals if you share its name. It has already forgotten what we gave it, and it does have that context. Like if we look at the context that we're feeding this thing, if we go over to our on-prem and we refresh, it has the conversational history. It knows. And yet, because it is such a small model, it's going to struggle with inference. And so if we were to ask it, if we were to inject our data, in fact, let's clear our history first and then inject our data. If we were to say, tell me, or what can you tell me about this data and what are my worst performing machines? If we were to pass this to our external agent, it would actually do pretty well with this. It wouldn't be too complicated a question. It could actually go through and chug through and sort of understand. The problem here is we are generating so much data. We are sending so much data that it's going to really chug through this. It needs to not only tokenize everything that we've said, it needs to infer based upon that data set. It needs to do a lot of training extraction to figure out, okay, what even is this kind of data? What am I looking at? This is going to take forever. The benefit, of course, is that we get local control. And if we were to go with a smaller model, in theory, we could get faster. But the smaller your model gets, the less efficient it's going to be in terms of actually getting you the right answer. So you can start to see we now have a new trade-off. What was the old trade-off, which was, okay, we need hard drives in order to store this data, et cetera, et cetera. Now the problem is we need RAM to load the model in, and we need processor availability, or we need some sort of API like Metal if you're using Macs, or Vulkan or CUDA. We need some sort of way to connect the processing to our GPUs to offload that data. So we now have a new logjam, which is RAM and graphics processing units. And so you can see here, okay, it's giving us some information, although it's very sort of generalized, it's not super useful. What does make this more useful is when you're doing this sort of thing. So I ran this a couple minutes before we joined. You can see this is doing some inference, and this is basically just passing to a local ONNX model. Now, YOLO, if anyone's not familiar with that, that's you only log once, you only look once. It's an object detection model. And this is like the perfect use case for it because it's an isolated single purpose. I'm not asking it to tell me facts about what it's seeing. I'm not saying, hey, can you detect the sentiment of the person? Like, just tell me there's something in the frame. And if it's in the frame, what is it? Right? This now becomes a much more logical thing to use this technology for. And you can sort of start to get the sense of it is no longer you have to do this thing or this thing or this thing. It's an option depending on locality, and it's an option depending on actual versatility. So if you're pushing something like this would make no sense to send out to Claude. I could send the data out to Claude and say, hey, can you tell me like what do you see in this image? But the latency of sending that out, doing the detection, in that case, if I wanted, the way this is working, just to give you a little bit of context, this is catching a single frame of a video stream, okay? And that's processing that frame. Because that frame is refreshed like once a second in the way that I would implement this for a viewable port, I don't necessarily want to have that flow going out to Claude and then back. The latency in that case would make this unusable. And so the trade-off is, yes, on my server, the model is going to perform worse, but it's actually going to latency-wise be much quicker, and therefore my interactivity with it is going to be way, way better. So you sacrifice quality, but you get interactivity. And that is sort of the truth of using these external agents. And what I really wanted to communicate to everybody today is that these systems, they have their uses. And the good thing is when you're using FlowFuse, Node-RED, whatever, these systems, they can be flexed to be anything. In this case, I'll give you a good example. Our off-prem is relatively simple. We're building just sort of a chat agent. For on-prem, we have to do a lot more. We have to send out the data to be processed. We have to prepare the Olama request. So we actually have to reformat the request to be able to take that history and feed it to Olama. We then have to, when that comes back in, we have to wrap that request and transform it from the array response that we got back into sort of like a string that we can process to the end user. But because we have control in FlowFuse of doing all of this, we can dictate exactly what the end state looks like. And instead of just being an application that we go out to, that we go talk to, it is now something that we can bring a native data object in and work upon that object. So this is a pretty powerful solution. You can do pretty much anything with it, which is great. It also means that you can interact with pretty much any resource you would want to interact with. You can do database calls, you can do local system calls, you can have streaming data inference. There's even, if you look at Hugging Face has like sentiment analysis, it has body posing analysis. There's all sorts of things you can do with this. What you really need to be aware of is a handful of things, really 3 things, I think. 1, you need to be aware of the balance of resource and your expectation. The servers I'm running my local model on, they're a 2018 Intel Mac. One has 32 gigabytes, one has 64 gigabytes. My expectation for running Quen, I can only run a certain quantized model because although I have the RAM to run it, my CPU, it's CPU inference only, which is not going to be effective enough. I'm not going to get Claude performance, which means my prompting has to be very specific. My intention has to be very specific. And what I expect out of it has to be sort of wrapped with the understanding of, hey, this isn't going to be like using Claude online. Okay. The other piece of that is really having a firm understanding of the question that I'm asking or the problem I'm trying to solve. I had a conversation with someone earlier this year that I think is a perfect example of way this system works. They had a facility where they were producing machine parts, and the problem was that those machine parts would go into a metal pan, and then that metal pan would have to be tracked. But you can't track with paper tags because the metal pan gets washed in high temperature cleaning solution because it's covered in oil. You can't use certain materials because it degrades the pan and potentially harms the part, and it's like aerospace level, so you can't do that. You can't really do like NFC because there's so much metal involved in this that you're actually going to get interference. And there's just all these reasons that like the tracking that we would do is not the best solution. Their solution was to have paper tags that they basically replace at every step of the process because it's the only way they can tag that particular system. In that case, this is a perfect model, right? If you have computer vision that's able to go out and detect, it can take a snapshot of the pan that's in front of you, and it can say, okay, this pan contains this item, and I can look at the timestamp for when that item was captured. I can then say, okay, well, this item is likely for this work order because it's attached to this workstation, and I'm detecting this part. That is a perfect local model inference use case. I don't need to send that out to ChatGPT. I don't need to send it anywhere else. Then maybe I want to get a report of, okay, what workstation is the best workstation? Which one is the most efficient? In that case, it might make sense to call the OpenAI API to send that information out and say, okay, here's all the reported data. Can you tell me which was the best performing machine? Look at all this data. Give me a human readable report. Perfect. That makes perfect sense. If I then want to take all of those reports, parse all of those reports and compare them to the recorded data to see how accurate our sort of tracking was. Say, I have like quality inspection checks and I want to measure what was the reported quality from the people who have done the checks versus the inferred quality from the AI versus the actual data that was used to create those two things. All of a sudden, now it makes sense to use a platform solution like what FlowFuse Expert is, because I can take all that data and rapidly across all layers, all strata of that data, compare, contrast, understand. So you start to see that this is more of an ecosystem solution as opposed to a singular isolated solution. And finally, and this is perhaps the most important part of this, is really understanding the amount of control that you want will dictate what you can do with these things. Okay. If you need extreme control, if you have a governmental contract, right, and they have expectations, data can't leave, it's, you have to understand, okay, we'll do everything locally, but that requires either investing in a maybe even like $100,000 server rollout of a cluster of CUDA enabled GPUs to do local inference at the level that it needs to be, or your SLA, your provision, your understanding needs to be brought down, and you can say, yes, we can process locally entirely, but it means you need a human in the loop. You need to have someone reviewing all this. So those are really the three most important things I think you should take out of this. So with all of that said, we have a couple more polls that I'd like to share out. The first one here, I would really like to understand from you all how you currently use external AI. And specifically, some of these are going to be like, code development versus local LLM functions could sort of be the same thing, but I'm interested in seeing where the sort of interest of this group comes from. Because a lot of what we've shown today really gets drawn down to use cases. That's the core argument. So while we're doing that, I'm also going to open up our Q&A and I'll see if we have any questions. So we do have a question. The conversational history, is it independent by instance, by site, by customer? How much history are you considering for answering that question? Revibration. Okay. The answer to all of that is yes, which is, let me explain. Because you set this as a flow context state, it doesn't have to be flow context. It could be global. You could push it out over MQTT if you wanted. You can make this a string and have it be, constantly pushing to some other database somewhere. In theory, you could use something like QuestDB and just store the string as a binary. You could do literally anything with it. So when you ask, is this independent by instance, by site, by customer, it is how you develop it. In this case, if you are, building a chat application, what I would say is probably having a user ID, like a login flow that someone has to do that then appends all of their requests with their like a UUID or something, in which case you could limit it down to customer, to site, to instance. But there's about a million ways you could do that. And in terms of how much history you're considering for answering that question, I think the max depth that I have set for this flow right now is 10, but you can, and I'll share this flow on GitHub after this, you can actually change how much, like how deep your inference and your history is. But again, you have to consider what that means for cost. It means you're sending out hundreds of questions that you've already answered before, got answers for as part of the message context. You need to understand it's going to take a couple minutes to get that answer. Cool. So great question. I'll go ahead and end this poll. It looks like a lot of us use it for code development. I'm a big fan of that. Again, human in the loop quality consideration, data processing, 100%. Cool LLM functions, absolutely. It looks like we actually have quite a few people who use them for other purposes, and a handful of people who also just don't use it at all, which is totally valid. So I will also ask this question, which is what tool you're currently using. And this one's a very interesting question because often you're using a tool that you don't know that you're using. That is where this gets tricky. I think when we go to Claude.ai, like we're all familiar that we're using Anthropic, right? There are 1,000,001 solutions that say, oh, we're AI, where we give you this cool model, this cool thing, this whatever. And then you get under the hood, and 9 times out of 10, it's just a router to OpenAI. I will say, there are exceptions to that. FlowFuse Expert is a great exception. We do route out to other AI for processing, and yet the real value happens internally through the remixing, through the rights assignment, things like that. So there's quite a bit more value to that. So a lot of people, obviously with the code piece that we just talked about, we use it in the IDE, Cursor Copilot, great. Let's see, Gemini is pretty up there. OpenAI is great for conversational stuff. And then the last one here, and I know this is like a lot of questions, so I appreciate you all persisting with me here. I want to get an idea of sort of where you see the most value in your use case for AI. And the reason I ask this question is one of the most challenging things about AI has been that it has been marketed as sort of a panacea, that it is a solution for all things. It's sort of that earlier problem that I was talking about where we have all this data, we don't really know what to do with it. So maybe the solution is like, let's just throw AI at it. And then AI is going to get us our solution and it'll be beautiful and we won't have any more problems. But that's just not true, right? That's just not true. And so we in the AI space, especially in the industrial space, we're struggling with the reality of what AI has been marketed as versus what the actual value of it is. It's not a panacea. It doesn't solve all things. It's certainly not going to I've said this a couple times in sort of individual conversations where there's a lot of okay, cool. You can, have a therapist in ChatGPT. You can get it configured to be like a healthcare professional. No, right? Like, sure, you could, and maybe in the future, maybe, but like having it manage HIPAA compliance and having it manage all these things, like that's too far. And so, the value there is not there. And when people see a use case like that, they're like, oh, AI is nonsense. Whereas if you offer something else like human in the loop support agents, that's a perfect example, right? If everyone is asleep, if you have an organization that's in Germany, but you have a lot of US clients, there's going to be a time where everyone in your company is asleep. In that case, having an agent that can respond with RAG, retrieval augmented generation, to grab documentation and order status and information and all those things, be able to provide that answer and say, hey, I'm a robot. I can get a human in the call if you need, but here's something that might help you. That is actually helpful. That is legitimately a helpful thing that can be done. And looking at the answers here, it seems like you all actually have a lot of that same interaction. Like data analytics and data processing is super, super useful. Contextualization of operations is great. Being able to look at a bird's eye view is super helpful. And there's actually another question that came in that is sort of relevant to this. So you talk about the dependency on use cases. Can I ask what use cases triggered FlowFuse to develop and provide these capabilities? 100%. The reality is that we have so much value in our data. And one of the sort of core underlying things about that data that make that value make that value extremely present but hard to get. So let me rephrase that. What makes the data extremely valuable but hard to extract value from in most industrial implementations is the context piece of it is often just sort of thrown away. Okay. You have a million vibration centers and a million vibration sensors, and you're trying to get contextual information about those sensors out. And yet, are you constantly reporting timestamp of the generation, the device name, whether it's part of what site, in what proximity to the other sensors are they? What version of the software that is monitoring that are you actually running? How has it been updated? Has there been any changes to that structure? All of those things on a human level, that's meta-contextual information. So if you have a vibration sensor or a series of sensors that have failed, and you as the human know that, oh, well, that whole line just got updated last week, right? If you don't have that context when you're doing the data analysis, if it's just rote analysis, all you're going to get is those sensors have failed. That's it, right? When you push it through something like FlowFuse Expert, and this is really where I think we saw a lot of value, FlowFuse by its very nature and Node-RED by its very nature generates an absurd amount of context of the flow state of when the node was created, when it's been interacted with, when it generated that data, from what instance it was generated, has it passed between instances. All of that context is such immediate and easily accessible, enrichable data for context that not having something like the expert is silly. Like it's truly silly. You have, it's sort of like, oh, my lobster is too buttery. It's like that complaint, right? You have so much data. It's actually just about getting that data and context out. And I think that is sort of the big use case for FlowFuse Expert. And what really inspired us to do that is just the value is so readily apparent. So yeah, looking at the answers to this question, most value, again, data analytics is sort of top of line. Human in the loop is next, which isn't surprising. Context of operations, and no value right now. And you know what? No value right now is an absolutely justified answer. There are dime a dozen providers, and actually getting, a valuable implementation out of this is not always as easy as the marketing might lead you to believe. What I will say is if your answer is no value right now, I would say take a look at the FlowFuse Expert. Okay, take a look at when I share this code, take a look at that. Because I think once you start abstracting away the idea that sending out to an external agent means I'm losing control, if you get rid of that idea and you put into your mind instead, I can apply the controls. I just have to think about what parts of Claude I'm losing or what parts of ChatGPT I'm losing. All of a sudden, the value propositions start to surge in a really interesting way. So I would definitely, if your answer is no value right now, I'd play around a little bit and think about this is sort of my way of thinking about it. If I could make my Anthropic instance act like a junior engineer, what would I want them to do? And how would I measure whether they were successful or not? That will inform how you build the flow, and I bet you'll find more success than you think. Well, awesome. That was our conversation for today. As I said, I will share all of this code on GitHub. You can actually get in this instance as well. I'll be sharing a live instance that you can play around with and see what it looks like. Definitely go ahead and take a look at that. If you have any feedback, please let us know. Again, there's going to be a poll that will pop up at the end of this. So please feel free to let us know how this was and let let us understand what you thought. And yeah, I am super excited about this. I'm super excited for y'all to play around. You could always reach me on FlowFuse. If you go to YouTube and search FlowFuse, that's me. I'm the person that does all that. You can also at me on GitHub. You can submit any issues for it. And you can always email me, Christopher@flowfuse.com, if you have any questions. As I said earlier, we're going to be at Hanover Meston next month, and we're actually going to be doing a lot of cool stuff here. So 100% take a look at that. But until then, thanks again, and until the next deployment. I'll see y'all next time.